Once you're done coding your circuit up as a module in Verilog, you're going to want to test it to make sure that you implemented it correctly. And so for that, we'll implement what's called a test bench. That we're going to build another module that contains the module that we're testing, and the test bench is going to let us apply inputs to the X and Y inputs of our module. It's going to allow us to control those inputs as a function of time. So we could decide we want X to be low for a while and then change to high at some point and then come back down to be low and then go be high again. And then for Y we might decide it should be low for a long time and then later change to high. And we're going to use this test bench to simulate this circuit with these given inputs, and we're going to be able to observe the output that is the result of those inputs. And we can look to see, is this output what I would have predicted for these inputs, and therefore do I have confidence that the circuit that I designed actually works. So let's take a look at an example test bench. So a test bench, as we said, is a module just like the Verilog modules we've made before, and we've given it the name SC test. You'll also notice that there's no ports. Instead, our test bench only contains one component. That's this SC block. And we've given it the name SC1, and an SC block turns out to have two inputs, A and B, and two outputs, S and C. So our component looks something like this. Here's our block, SC1, and it has two outputs, S and C, and two inputs, A and B. So we've created two wires, S and C, that we've connected to the outputs of our SC block. To connect to the inputs, we're introducing a new component called a register, or for short, reg. And this is a special component that we're only going to use in test benches because it allows us to directly control the value that's driven on the wires A and B. So let's now see how we can control our input values A and B and collect the output values of our simulation. The next block of code is what's called an initial block. This initial block is code that we'll only ever use in a test bench. The first two commands describe collection of output data. So this dump file command is specifying the name of a file that we can output the values of signals in our modules. And it's coupled with this second command, this dump vars, which specifies which signals to output. It takes two parameters, a number and the name of a module. Here, the number 0 means to include the signals in all submodules of the specified module. Recall that SC test is the name of this test bench module, and so what we're specifying is that we should collect all of the values of signals in the SC test module and all of its submodules. So together, these two statements are saying that for the whole run of the simulation, we should collect all of the values of wires in all of our modules and put those into an output file called sc.vcd, which we can use to visualize them later. The next block of code is the one that we use to control the values of our input signals A and B. And again, this is code in a style that we'll only ever use in a test bench. What I'm showing here is starting at the beginning of the simulation, I want to set the value of A to 0 and the value of B to 0. Then I specify this command number sign 10. And what the number sign means is I'm specifying an amount of time that I want to pass. In this case, 10 time units. And so I want that time to pass before I set A and B to new values. So let's see what these signals would look like. So we can draw the value of these signals over time. So the code says that A should initially be 0 and B should initially be 0. So A starts at 0 and B starts at 0, and this should be true for the next 10 time units. Since these values weren't told to change, they're going to hold whatever value they were given. Then after that 10 time units has passed, A should remain as 0 and B should change to 1. So at time 10, B is going to change to 1, but A is going to remain at 0. We're going to do that for another 10 time units. At the end of that 10 time units, we want to set A to 1 and B back to 0. And we're going to hold those values for another 10 time units. Then finally, at the end of that 10 time units, we're going to set A to 1 and B to 1. So A is going to stay at 1 and B is going to return to 1. And we're going to do that for another 10 time units. And after that 10 time units, the next statement is a finish command. And this is a directive to the simulator saying we should end the simulation. And so the simulation is going to end at that point. So all of that code that we just described all belongs to the same initial block. You'll notice that my initial block included a begin and end statement to delimit the contents of that initial block because we had multiple statements. So all of this process begins at the start of the simulation and happens sequentially up until the finish statement, which ends the simulation. After this initial block, we see there's another initial block. So here's another thing that begins at the beginning of the simulation. We can have as many initial blocks as we want. That Verilog is inherently a parallel language. So this initial block is proceeding in parallel with the contents of the second initial block. The second initial block contains only one statement. Because it has only one statement, we don't need the begin and end statement for this initial block, although it would not be incorrect to include them. The one statement that this initial block includes is a monitor statement. So a monitor statement is like a print statement, but it's a special kind of print statement. It has syntax not unfamiliar to many normal programming languages in that it's got a block of text that includes some special patterns that we're going to replace the contents with the values of variables at the time the print statement is run. This first special group of characters is going to be replaced by the variable time. This is a special variable that whenever we read it, it provides the current time in the simulation. The rest of the special characters are going to be replaced with the values of our signals A, B, S, and C. So this statement is going to print out the time and the values of our signals. But it's not a print statement, it's a monitor statement. So as I said, a monitor is a special kind of print statement. This monitor statement will fire anytime any of my variables A, B, S, and C change. So anytime any of those change, we'll print out their current values and the current time. And this is the end of my test bench.